So in this module we're going to talk about model-based development and verification. You have been working on the project, and for the project you've been trying to kind of use a modeling tool like Simulink to kind of define your requirements. And this is what we're going to do in model-based. This is what we're doing in model-based development. So since there's a lot of issues associated with using a modeling language like Simulink or one developed by Skate for safety critical applications, there really is a dedicated supplement, DO331, that actually deals with model-based development. Okay, so if you look at the DO331 definition of a model, it's really defined as an abstract representation of a given set of aspects of a system that is used for analysis, verification, simulation, code generation, or any combination thereof. A model should be unambiguous regardless of its level of abstraction. And you see here, it's a fairly defined requirement, and a couple of things are quite obvious, of course. The fact of unambiguous. This is kind of the same attribute that we had for when we did requirements definition. So what you see that these models that you have can represent either requirements or software architecture. Yeah. And these models are really highly dependent on the modeling technique or modeling language that you have. On one end, this can be some kind of textual modeling language like the ones used, for example, for formal methods, or it can be like graphical, like some of the tools from Skate, like the Skate, for example, or the Simulink that you've been using for your projects. Yeah, so the supplement, so DO331, really addresses two forms of models. One are the specification models, and the other design models. And specification models are really used to describe the what. What it is the software is to do in terms of function, performance, and safety. Whereas the design models are really describe more how the software will be built. So in other words, what are the data structures? What is the data flow? What is the control flow? What are the detailed modules in there? So if you look at this, the specification models are really more like high-level requirements, whereas the design models are more like low-level requirements and architecture. Of course, they're not exactly the same, but they're like it. Okay, so what are some of the benefits of model-based design and development? Development and verification. It is really, and I'll show you this on the next slide, model-based design really gives you more of a Y lifecycle process. If you look at a standard V lifecycle, you have system requirements, you derive some software-specific high-level requirements, you come up with design, which is the low-level requirements, software architecture, and then you implement it, and then you perform all the integration and verification activities. On the other end, if you start using modeling language, a model-based development, we're really going to take these two blocks and kind of put them together. Yeah, so you're going to use maybe a tool a graphical tool like Simulink, and you come up with one tool in which you're going to show a model for both these spots. So what you get is you're getting a big chunk that really represents all these requirements. And a lot of these tools really are able to then take that model and convert it to code. Like in Simulink, there's tools like Embedded Coder or Simulink Coder that take your Simulink model and turn it into a piece of source code. In a lot of cases, you can even select that this source code adheres to software standards like, for example, MISRA-C. So what you see is there is a lot of there's more focus on requirements, because you really, especially when you talk about the design models, you really start looking at what it is, what are the details that I'm going to be implementing. And of course, the nice part is that you can simulate, so you can actually do already in simulation some early verification of these requirements at least. Now, because you use this model-based design, it leads typically to more of a reduction of unnecessary redundancy and inconsistency, because you have a clearer picture of what the system, or at least your software subsystem, looks like. Yeah. So as a result, you also get a better understanding of these requirements, and of course you get better interaction with customers because these models are really intuitive. Somebody can take a look at them and get a good idea of how these blocks all fit together. Of course, as I said already, you guys have been using Simulink. There is just a growing tool support, and also there is an evolving formal method support as well. And formal methods is really part of the next module. There is, of course, also some risk associated with it. You may lose, whereas when you take like the approach of doing system requirements, high-level requirements, low-level requirements, there are way more requirements reviews kind of enforced upon you, whereas with model-based design you could run the risk that you actually reduce the number of reviews. So you can, that's some discipline that you have to put into your process. Yeah, so also it means that the system engineering role is expanded. It will include these models because they have such an intuitive view. And one thing is that traceability is pretty difficult. Now you have a model, a graphical representation, for example, of your requirements. So now how are you going to trace certain functionality in these models, to either high-level requirements or system requirements? You still need to do this, and it's going to be tougher. Also, there's going to be some difficulties, if you want to make sure that you got your testing completed, of course. And there is some simulation credit controversy, where it's, if I take these models, I can simulate them before I generate the code and test it. What kind of credit do I get for that? Typically in the old D178B, traditional D178C stuff, you really write requirements, low-level requirements, then you derive the source code, and then you just take the source code, test it at a module level, perform integration testing, and then do hardware-software integration. So what you see is that you really don't do too much actual simulation with the requirements per se. But of course with modeling, these modeling languages are typically there so you can actually perform simulations. So how much credit can you take for that? Okay, so another thing, as I said before, and that's kind of typical of this V life cycle, models typically, they mix together the what and how. Yeah, so it's also a result, really hard to separate these specification design models. But there is some validation challenges. There is also a blurring going on between the systems and software roles. Because since you have on a kind of a block diagram approach, maybe if you especially use a tool like Simulink, you can actually, system engineers will have a better insight too in what's going on. But it also means that their role gets expanded. Okay, so if you combine traditional model-based development, that maybe have challenges, and of course, even though it's a more intuitive representation, people could still interpret models inconsistently. Now, when you have a model, you need to make sure you maintain it. How are you going to do that? Now, okay, so if you have, just like you had the coding standard, just like you had the design standards and requirement standards, if you use some kind of modeling language or modeling technique, you need to include model standards. And these standards, they must include methods and tools for developing the models. You have to describe what it is that what these methods and tools really are. What is that modeling language? For example, in Simulink, you have to define that you use these blocks, how do you use these blocks, how you define particular attributes of these blocks, how do you link these blocks together. There may be some style guides, like we saw even in the code standards, in terms of what are you gonna name these blocks, etc., etc. Are you gonna have certain input and output? How are you gonna define that? And then, of course, what are the design constraints within which you want to work? The model may give you a ton of different tools, but you may want to only say, well, when you design with it, there's a particular set of constraints. And especially when you, for example, do automatic code generation in Simulink, not everything that you would do in Simulink would necessarily be able to be converted to source code using a tool like Embed Decoder. Of course, you need to make sure you identify the derived requirements, and that's it really.